Hello class. Today what we are going to talk about is reflections. This is just another kind of transformation. Just like yesterday, in the last video, we had translations, which is just a slide. So if I take my pen and I just move it over, that is a translation. What we're going to talk about now is reflections. And what this is, if you take your pen and instead of sliding it, you take it and you flip it. All right, flip it. So, for example, the pink pen is a reflection of the orange pen across a line of symmetry right there, which is right there. All right, and it acts like a mirror. And as you know, in a mirror, everything looks backwards, right? Which is why one pen faces one way and the reflection faces the other way. Right? It's just like a mirror, everything is flipped over backwards. Now, in a reflection, all right, the line M, the reflection maps every point across your axis of symmetry, your line of reflection. All right? And it's a little hard to see with points, so I'm going to just take this, instead of having point P, I'm going to make triangle, and we'll call this APB. All right? And that will be mapped over here to triangle. And this is not going to be perfect because I'm just freehanding it, but that's okay. You'll get the idea. A prime, P prime, and B prime. All right. Now, you see, again, it is a mirror. Everything comes out backwards. Now, what's going to happen is one of two things. If point P is not on the line of reflection, then the line of reflection will be the perpendicular bisector of segment P, P prime. Okay, that means that since it's perpendicular, we're looking at the distance, right? And since it's bisector, it means the distance from P to the line of symmetry, to the line of reflection, is the same as the distance from the line of reflection to P prime. All right, the same is also true for A and A prime. So the distance from here is the same, that's a right angle, as the distance here. All right, the distance from A to the line of reflection is the same as the distance from the line of reflection to A prime. The distance from B to the line of reflection, pretend I drew that straight, is the same as the distance from B prime to the line of reflection. All right. Now notice these are not all the same distance. B obviously moved quite a bit farther than P did, right? So this is not a slide because the different points are moving a different amount, but it is still going to be a transformation because everything is moving in the same way. Right. Now you do have one other possibility, and that would be if point P is on the line of reflection, in which case it will not move. It will stay right there. Now, we do have a couple of shortcut rules if we are on a coordinate grid. All right, coordinate rules for reflections. And these are the basic things. If you have a point reflected in the x-axis, then the image will be, instead of AB, it becomes a negative B, because we're reflecting in the x-axis, so it's just moving straight down. And so it will be a negative B. If you're reflecting in the y-axis, so the vertical axis, you're moving across the vertical axis, so the only thing that changes is your x value, and it will change from AB to negative AB. All right. Other things we could reflect across would be the line y equals x, and when this happens, you change from the point AB to the point BA, or we could reflect over the line y equals negative x, in which case we go from point AB to point negative B, negative A. All right? And I'm going to do one better for you. I am going to give you these two here. What happens if you reflect over a line, a vertical or horizontal line that are not the axes? Okay? And what happens here? All right, so we're going to reflect over the line x equals x1, so something other than 0. And remember that since we're going across this way, our y values are not going to change. So we're going to have something, and then b is going to be whatever it started with, right? However, our x values are going to change because we're moving along the x direction horizontally here. So what are they going to do? Well, as we said a minute ago, we said that the distance from point P to the line of reflection is the same as the distance from the line of reflection to P prime. So we need to know what this distance is. How far is it from x1 over there to A, right? Well, this would be distance is a difference, subtract, so this would be x1 minus A. x1 minus. And then we're going to take that, and this would also be x1 minus A, because they're the same. So we can just take x1 and add it to x1 minus A. So x1 plus x1 minus A. And that will give you the location when you reflect over the line x equals x1, whatever that is, some other x, not the x-axis. So now let's look, if we reflect over a line y equals something, y1, whatever it is, not the x-axis. All right. So we're reflecting over here. A is not going to change because that's our x value, right? And this time we're going straight up and down, so the x value is not changing. So this is still going to be A, but we are going to have some new B value. But it's basically going to be the same thing we had up there because, again, the distance from here to here is the same as the distance from there to P prime, right? Well, what is the distance from point P to the line of reflection? Well, that would be y1 minus B. And so we'll have the same thing here. This would be y1 minus B, right? So that means the y value is going to be y1 plus whatever y1 minus B is. All right. And that's how this works. And just an extra little coordinate formulas, rules for when you are on the coordinate grid, not just those. That's some other ones. We do have a postulate here, very, very simple one. Just like the translation postulate said that translations are rigid motions, the reflection postulate says that a reflection is a rigid motion. Because when things reflect, it doesn't change their size, it doesn't change their shape. You are the same size and shape as you are in the mirror, right? Your reflection is the same as you. It doesn't change it, all right? Unless you're at the carnival. Anyways, glide reflection. All this is very simply a transformation. It's a composite transformation that includes a slide followed by a flip. So it is a translation and then a reflection is all it is. So if I take this and I slide it up and then I reflect it over. Glide reflection. That's it. And it really doesn't matter what order you do it in. All right. So let's take a look at this. Let's do some examples. All right. So exercise 1 through 4, we want to graph triangle ABC and its image after the reflection in the given line. Remember, what we're given comes first. This is the pre-image. The new one is the image. So let's take a look at this. We need to graph triangle ABC first. ABC, let's see, our scale is not going to work the way it is. We're going to have to change our scale. So we will go up by 2s. That work? Probably. Looks like 2s will work. So now I'm going up by 2s, and I think I'm going to have to do that on most of these. But anyways, so let's see. A is at -1.5. There it is. And we are going to reflect this over the given line. It wants us to reflect it over the y-axis. I am just going to go ahead and mark this. The y-axis is right here. I can't see it very well because it's right there on the axis, but that's okay. And now we're going to reflect it over. So how do we do this? Well, if you remember, we move perpendicular. And the distance from A to the line is the same as the distance from the line to A prime. Or we could just use our rules here. So we're reflecting over the y-axis, so that just means that point AB becomes point negative AB. So we are going to leave the y values as they are, and we are going to flip the coordinates, flip the sign of the x coordinates. So instead of being at negative 1, 5, A prime is going to be at the point 1, 5, positive 1, 5. Right there, A prime. B prime, instead of being at negative 4, 4, will be at positive 4, 4. And C prime, instead of being at negative 3, 1, will be at positive 3, 1, because we're reflecting over the y-axis. There it is. All right? Just like that. Just using the rules to flip them. I would like for you to pause the video, and I would like for you to work out number 2, 3, and 4. So let's look at number 2. I've got it drawn on there. Again, reflecting over the x-axis, and now we're coming down this way. We take a look at the rules real quick, and we see that reflecting over the x-axis is going to be A, negative B. So the x values stay the same, and we just change the sign of the y values. All right. So on A, the x value stays the same. We change the sign of the y values. It becomes negative 2. B prime, don't forget your little primes right there. So the x value stays the same at 4. The y value changes signs. It becomes negative 5. And C, the x value stays the same, and the y value changes signs to negative 2. So triangle A prime, B prime, C prime. All right. Now let's take a look at number 3. So we are now going to reflect over the line, got this drawn, reflecting over the line y equals 1, not an axis, so we cannot use these rules here. We're going to use these rules here that I gave you. And basically we're going to find the distance from the point to the line of symmetry, to our line of reflection, and then we add it to the other side. All right. So let's see here. A starts off at, let's see here, we're going over y, so that would means the y equals, nope, we're going over y equals 1. So yeah, that means the x values are not changing, we're just changing the y values. Okay, so that means A is going to stay at 2 something, so A prime is going to be at 2 something. Well, let's see, 2 right now is at negative 1, and we're going over the line y equals 1, right? And so 1, from 1 to 1, 1 to negative 1 there is a difference of 2. So that means I need to add 2 on this side, which puts it right there at 3. And there is A prime. Okay, let's see. B is right now 1, 2, 3 units below the line, so we need to move it 3 units above the line. 1, 2, 3, right there. B prime. C is way down here at negative 3. So that'd be 1, 2, 3, 4. So it needs to be 4 units above this line. And let's go ahead and put up points up here. So B prime is at negative 4 because that doesn't change. And this is now at positive 4. With these, it's easier to graph them first and then come up with the equation, with the coordinates. That stay the same, and this is going to be at 2, 4, 5. Like so. All right. Okay, so now let's take a look at number 4. So again, we had to change our scale so that this will all fit in there. So we're going up by 2's again. And we've got it graphed on there. Our line of reflection is x equals negative 3. So this is, here it is. And again, we can look at our rules. We can do it this way, like that. But these, honestly, it is probably easier to graph it. But still, we notice that the y values don't change because we're moving in a horizontal direction, purely horizontal. So the y values aren't changing. So we're just going to go straight across. Well, A is at negative 2 for the x, and we're going across negative 3, so that's a difference of 1. So I need to go 1 past that, and that will be A prime. B also is 1 unit away from the line of reflection, so I'm going to end up 1 unit on the other side of the line of reflection. So there's B prime. C, on the other hand, is 1, 2, 3 units from the line of reflection, so we're going to go 3 units past the line of reflection. 1, 2, 3. Puts it right there. And there's C prime. And there we have triangle A prime, B prime, C prime. And let's go ahead and get the coordinates down for this. Again, because remember the y values didn't change because we moved horizontally. All right, not too bad. Hopefully you've done stuff like this before. Now you may or may not have ever reflected across the line y equals x or the y equals negative x. So let's take a look at those. So on this first one, number 5, they have given us, which one? Okay, so they have given us the pre-image, and we need to graph the image. All right. So going across the line y equals x, I'm going to go ahead and graph that in here. And let's take a look at our rule. Our rule for this, if AB is reflected over y equals x, then it turns into BA, because y equals the x, and x equals y. Is basically all that's happening here. So we're just inverting the points. So let's take a look at this. It might actually be easier if we wrote down the coordinates. So I am going to do that real quickly. So we've got these original coordinates written down. Now what I'm going to do is I'm going to use the rule to write down the new coordinates for the image. That's the pre-image. Let's write down the image. So A prime, all we do is we switch x and y. So it becomes to -3. B prime switches from being -1, 2 to being 2, -1. C prime switches from being -1, 4 to being 4, -1. And D prime, instead of being -3, 4, becomes 4, -3. And then we plot them because it does want us to graph them. And there we have square A prime, B prime, C prime, D prime. That could get a mouthful with all the primes in there. All right, and there it is. It does need to be labeled correctly. All right, this is not just a translation. It looks like a translation because it's a square. However, notice A went farther than B and D went even farther. It did just move down, or this would be A, D, C, B, but it's not. This is a reflection. Okay, I would like for you to pause the video and see if you can't reflect number 6 over the line y equals -x. Use those rules there. All right. All right, let's see how you did. First, let's draw in the line of reflection. So y equals -x is going to look like so. And let's take a look at the rule here for y equals -x. Let's see, y equals -x goes from AB to -b, -a. So first they change position, x switches with y, and then we negative them. Basically, you do just like you did for y equals x, but you change the signs. All right? So again, I am going to do this, because this one can be hard enough. I'm going to write down the coordinates of the pre-image, and then I'll write down the coordinates of the image, and then plot them. So those are written down. Now the rule was -b, -a. So that means for A prime, instead of being 2, 0, it would be, well, technically -0, but there's no -0, and then -2. B prime, okay, so first they flip places, so I'll have 3, but I change the sign, so -3, and then -5. C prime, they change positions and we switch the signs, so -5, -2, and D prime, instead of being 1, 4, becomes -4, -1. And now we plot the points. And there we have polygon A prime, B prime, C prime, D prime. Didn't draw it just wonderfully, but you get the idea, kind of wiggle. All right, not too bad. Now let's take a look at 7 and 8. Here, what we want to do, we want to graph triangle JKL with those vertices and its image after the glide reflection. Okay, this is a composite, and so what is going to happen, we're going to have a translation, so we're just going to slide and then a reflection. So we're going to slide and then we're going to flip. All right, so first off, let's graph the original. Let's graph the pre-image. So there it is. Pay attention to your scale. Notice it is going up by 2s. And I went ahead and I wrote down the points down here as well. And so the first thing we're going to do is a translation. Okay, so we're just going to have J prime. And all we do, remember, is we just add or subtract whatever it says here. So instead of 3, we'll have 3 minus 6, which is negative 3. 1 minus 1 is 0. For K prime, we have 4 minus 6, which is negative 2, and 2 minus 1, which is 1. And then for L prime, we have 1 minus 6, which is negative 5, and 3 minus 1, which is 2. And let's go ahead and plot that, just because. So there we have triangle J prime, K prime, L prime. And from here, we're going to do the reflection across the line y equals negative x. So let's go ahead and draw that reflection in here, that line. We are going to do this using the coordinates. All right? So remember the coordinate rules for a reflection over line y equals negative x is to be negative a, not instead of ab, it becomes negative b, negative a. So they switch places and they both change signs. So so J prime prime, again, we're coming off of J prime. They switch places and they both switch signs. 0 doesn't really change signs, it doesn't have a sign. But there are positive 3, negative 3 becomes a positive 3. For K prime prime, they switch places. So 1, negative 1, and then a negative 2 becomes a positive 2. And for L prime prime, the 2 moves to the front, becomes negative 2, and the negative 5 goes to the back and becomes positive 5. And then we graph them. And it's really only this one that we are interested in, not the intermediate one. And there it is. I got a little cramped. I really wish they had given me a larger graph with a bigger scale, but whatever. We take what we got, right? All right, so now what I would like for you to do is pause the video, work out number 8, and then come back and see how you did. All right, so we've got it plotted. I've got my points there. And first thing we do is the translation. So we just have to do the little math that it gives us there. So J prime, x is x, so 3, and then y minus 4, so 1 minus 4 is negative 3. K prime, x is x, so that's 4, and then 2 minus 4 would be negative 2. And then L prime, again, x is x, so that's 1, and then 3 minus 4 is negative 1. And let's go ahead and plot it. So there's that. Now we are going to do the reflection. That's the glide, and then the reflection. And this time we are going to reflect across the line x equals 1. So that would be this vertical line right here. And so the way we're going to do this is it's easiest just to count on these. We could use the equations I gave you, but it's really easy to count. So let's take a look at this. J prime is how far away from the line of reflection? Well, J prime is actually on the line of reflection, isn't it? And since it's on the line of reflection, it's not moving. So J prime prime is going to be at the same place. 3, negative 3. Doesn't move. All right. K prime is 1, 2, 3 units to the right, so we're going to move it 1, 2, 3 units to the left. And there is K prime prime, and that is at negative 2, negative 2. And then we have L prime prime is 1, 2 units to the right, so it's going to move 1, 2 units to the left, which puts it at negative 1, negative. I got these backwards. Oops. Let's fix that. I labeled them wrong, didn't I? L doesn't move. L is right there on the thing at 1, negative 1. J is this one down here, isn't it? So J is now at 1, negative 1, negative 3. Negative 1, negative 3. There we go, that's better. You can't see it. There it is. Now you can see it. Get my head out of the way. Okay, so there's that. Not too bad. Let's take a look at these down here. These are actually quite a bit easier. We just want to identify the line of symmetry, if any. All right, so where is the line of reflection in the word moon? Let's see it. I can't cut it this way because the M doesn't flip over. I can't cut it this way because M and N don't work, and I can't. Yeah, so this one has none. None. Okay, let's try this one. How about the word wow? Well, again, I can't flip it over because if I flip it over, it's not going to quite work. But I could cut it this way, right? Right down the middle of the O, because then it's going to flip over. This half of the O matches that half. The W matches the W, so there it is. Kid. Well, I can't do it that way because K and D definitely don't match up. However, if I cut it in half like this, the top of the K matches the bottom of the K, the top of the D matches the bottom of D, I matches I. We're good. And, yep, same thing with doc. Go that way, like so. So that was pretty simple. Anyways. Okay, now let's take a look at number 13 here. 13 is a little bit interesting use of reflections. And what we have here, and I need to zoom out, just touch, there we go. We want to place a power strip along wall W that's going to connect to computers. We want to know where can we put this so that we have the least amount of cord, all right? Because we don't want a whole bunch of cords staying stretched out everywhere to trip over, right? So here's how this works. It's a little odd, but that's okay. What we're going to do, we are going to reflect computer A over line W. So if I reflect its position over line W, that puts computer A right here. This is A prime, image of A. And then what we're going to do is we're going to draw a line from B to A prime, because the shortest distance between 2 points is a straight line, right? So from B to A prime, we have that. However, I can't actually put it here because computer A is right there, right? However, here's the thing. We want to reflect from this intersection up like this to computer A. Well, this is a reflection too, isn't it? And if it's a reflection, that means that this is congruent to that. And so what this does, since BA prime is the shortest distance because it's a straight line, that means going from B to this intersection point right here, we would call it X, to A is the shortest distance to get to this wall and then back to computer A. And I know that one's a little bit odd, but it does work. It's so hard to do that in real world unless you take your measurements and stuff and put them on a grid and a piece of paper, and then you can do that to figure it out. So it's pretty good. But there it is. There's reflections. Biggest thing, remember that the rules here, the coordinate rules, those are a big deal. And also the very important thing is to remember that on a reflection, the distance from the image to the line of reflection is the same as the distance from the pre-image to the line of reflection. All right? Hopefully that helps, and I'll see you in the next video.